Hello there, welcome to Test Review A for Chapter 4. I just want to talk to you a little bit about Section 4.6. We're not actually going to be working any of these problems, but you do need to know what it is for potential multiple choice or true-false question on the test. So you can see here, just reading through this, some functions do not have antiderivatives, which means you can't integrate. Okay, you can't find the area under the curve using the fundamental theorem of calculus. So you have to approximate the area under the curve, and doing a Riemann sum using rectangles will give you a lot more error than the two techniques I'm going to describe now. And you just need to know what the two techniques are. The first is the trapezoidal rule. And you can see if you use trapezoids instead of rectangles, right? So instead of squaring off the top, you use trapezoidal shapes to follow the curve. You can have very, very little error and really get a very close approximation to the area under the curve. So really, this formula, you do not have to. You're not going to do any math on these. This is if you were taking the AP test, we would do some examples, but I wouldn't really use this formula. The area of a trapezoid is the base times the average height. So you would just find the average height of each trapezoid and multiply by the base. And this formula is just a fancy way of saying that. All right, and there is another rule with a formula. It's called Simpson's rule. So Simpson's rule, here's the formula. You don't have to memorize it, but it can even be even more accurate than the trapezoidal approximation of areas under a curve. So all I need you to know for the test is what the trapezoidal rule and the Simpson's rule is for. It is to estimate the area under a curve when the fundamental theorem of calculus can't be used. So you can't integrate. These are two formulas using trapezoids and using this formula that can give you a really close estimate of the area under the curve. All right, so now I'm going to work all of these problems for you from page 248. Okay, all of these are what we call indefinite integrals, so we are not going to be plugging in numbers at the end, so all of our answers will have a plus C. And make sure on the test that all of your indefinite integrals include a plus C in the answer. All right, or I will count off. So our first one is 1 over x squared dx. I'm going to rewrite that as x to the minus 2 dx. All right, and taking the antiderivative, we would add 1 to the exponent. That would be negative 1. Negative 2 plus 1, negative 1. But I would need a negative out front so that when I take the derivative, negative 1 times negative 1, I would get 1. All right, and so cleaning that up, I don't want any negative exponents in the final answer. That would be negative 1 over x plus c. And of course, you can take the derivative of that to check and see if you got the right answer. Okay, number 10. Number 10, we have 1 over 2x all cubed dx. Now I'm going to rewrite that. First of all, if you cube 2, you get 8. So this is the same as 1/8 x to the minus 3 dx. Okay, cube the x, cube the 2. So that makes 1 over 8, and then I'm going to bring that x cubed up top and rewrite as x to the minus 3. Now this is pretty easy to take the antiderivative, add 1 to the exponent, so that'd be x to the minus 2. But I would need a negative 1/16 out front. So negative 2 times negative 1/16 would be positive 2/16, which is 1/8. And now I'm just going to make that exponent positive. So that would be negative 1 over 16x squared plus c. Don't forget the plus c. I had a student one year forget all the plus c's, and I had to take off 1 point on like 7 different problems on the test. Otherwise, he would have made 100 on the test. So don't let that be you. All right, number 16, we have x squared minus 2x plus 3 dx. Okay, I'm not really going to have to rewrite this. I can just kind of eyeball that. So for x squared, the antiderivative would be 1/3 x cubed. For 2x, the antiderivative is x squared. And then for 3, it would be plus 3x. And then plus c. So many students, when they get to a constant, forget and take the derivative, and then it would just make that 0 and it goes away, and they forget that term. That's why you want to check. You won't mess that up if after every antiderivative you check by taking the derivative. All right, number 18. We have the square root of x plus 1 over 2 times the square root of x. So let's rewrite this as x to the 1/2 plus 1/2 x to the minus 1/2. All right, 1 over 2 root x is the same as 1/2 x to the minus 1/2 if we bring that root x up. All right, now I can just eyeball this to take the antiderivative. It's going to be add 1 to 1/2. It's going to be x to the 3/2. But I would need a 2/3 out front. And then x to the 1/2. I'm going to hold off on the sign here because I don't. All right, and I would need, no, we're good there. And we'd have a plus, so take the derivative, 1/2 x to the minus 1/2. So that's good. Plus c. All right, brilliant. Number 20. So number 20, we have the 4th root of x cubed plus 1 over 2 root x. Okay, so the number that's in the crook of the radical is what, if you were writing this as a fractional exponent, that would be in the denominator. So let's rewrite this as x to the 3/4 power. And this is going to be plus 1/2. And then root x on the bottom, if I bring it up top, that's the same as x to the minus 1/2 dx. Okay, so let's take the antiderivative. If I add 1 to 3/4, that's like adding 4/4 to 3/4. So that's going to be x to the 7/4. What fraction would I need out front when I brought the 7/4 down and multiplied? It'd give me 1. Well, it'd be 4/7, wouldn't it? And then I'm going to have x, I'm holding off on the sign, x to the 1/2. All right, and when I bring that 1/2 out front, well, it's the same as this one right here anyway, isn't it? And it would be plus c. All right. So that, oh, I'm sorry, I looked at the wrong thing there. I looked at 18 on that, so I apologize. So it's just 1 there. I wrote the problem down wrong. Well, if you watched it again, you probably learned something there. So that'd be x to the 3/4 plus 1. So that's still going to be 4/7 x to the 7/4 plus x, right? The antiderivative of 1 is x plus c. All right, so my apologies for that one. Let's see if we can fit 24 in here. All right, I'll be a little more careful on writing this one down. So I've got x squared plus 1 in the numerator over x squared. So what we can do is rewrite this. So I'm going to do an extra step here, but this is the same as x squared over x squared plus 1 over x squared. I've had students that struggle with this, but you see how that you have a common denominator. This and this is the same thing. Now, what's x squared over x squared? That's just 1. What is 1 over x squared? That would be x to the minus 2. And now it's a pretty easy antiderivative. The antiderivative of 1 is x. And then you would have x to the minus 1. But I would need a minus out front, right? Negative 1 times negative 1 would give you a positive. And so getting rid of the negative exponent, you'd have x minus 1 over x plus c. So I want you to at least do that much on the test. All right, that's good through 24. We've got 4 more to go. Okay, number 32. All right, here we've got t squared minus sine t. All right, so that would be 1/3 t cubed for that part, and then plus cosine t. Derivative of cosine would be minus sine, and then plus c. Brilliant. 36. So 36, we have secant y times tangent y minus secant y dy. Well, let's rewrite that integral. Let's go ahead and distribute the secant y, because I think I see if we do that, we won't have to use any kind of u substitution or any other methods. And this is just a pretty easy antiderivative. The antiderivative of secant tangent is secant y. And then the antiderivative of secant squared would be tangent y. So secant y minus tangent y plus c. And take the derivative of that to check, but it works. Now number 53 is going to take up most of the board, so I'm going to go ahead and do 60 and then come back to 53. So number 60, we have a of t is equal to minus 32. And just reading through it, it says a balloon rising vertically with a velocity of 16 feet per second releases a sandbag at the instant it is 64 feet above the ground. How many seconds after its release will the bag strike the ground, and at what velocity will it hit the ground? Okay, we need to get our 3 equations here. We know that v of t, we're going to integrate negative 32 with respect to t. So that's negative 32t plus c. The c is the initial velocity, and it said in the problem our initial velocity is 16. Then s of t, our position function, let's integrate minus 32t plus 16. That's minus 16t squared plus 16t. And then our initial position was 64. So part A says, how many seconds does it take to hit the ground? Well, if ground level is 0, we're just going to set 0 equal to minus 16t squared plus 16t plus 64. Now let's see if we can factor this. If I factor out a negative 16, I would have t squared minus t minus 4. But looking at that, I don't think that I can factor that. It's either 4 and 1 or 2 and 2, and I can't get a negative 1 in the middle. So let's use the quadratic formula. A would be 1, B is negative 1, C is negative 4. So I would have negative B, which would be just 1, plus or minus the square root of negative 1 squared minus 4 times 1 times negative 4. You will need to know the quadratic formula for the test. All over 2 times 1. So that's 1 plus or minus the square root of 1 plus 16, square root of 17, over 2. One of those is going to be negative. So we're not going to have a negative time here. The other one is positive, and if you put that square root of 17 in your calculator, add 1, and then divide by 2, you'll get 2.56 seconds, which makes sense. That's a pretty believable number, so it passes the sanity check. Then part B, what is its velocity when it hits the ground? So that would be v of 2.56. So we're just going to plug that into the velocity equation. Negative 32 times 2.56 plus 16. All right, and just checking that's negative 65.9 feet per second. Makes sense that it's negative because it's going downward, and that signifies a negative velocity if you've had physics class. All right, so yeah, there we go. I got one more to work, number 53. Okay, so 53 is a differential equation. It says solve the differential equation. We have f double prime of x, voice just cracked, is equal to x to the minus 3/2. We know that f prime of 4 is equal to 2. And we know that f of 0 is equal to 0. So what we're trying to get to when it says solve the differential equation, I'm trying to get what is the equation for f of x. So I've got to go up 2 levels from f double prime to f prime and then to f of x. So f prime of x, going up 1 level, we would integrate f double prime of x. So x to the minus 3/2. So we're going from the second derivative to the first derivative. That's going to be x to the minus 1/2, but I would need a negative 2 out front. So negative 1/2 times negative 2 would be 1. Okay, plus c. So it says f of 4 is equal to 2. Y is 2. So I'd have 2 is equal to negative 2. And I'm going to go ahead and rewrite this as a fraction. Negative 2 over the square root of 4 plus c. So that would be 2 is equal to negative 1 plus c. So c is equal to 3. F prime of x then, so going up 1 level, would be negative 2x to the minus 1/2. I'm going back to writing it with the negative exponent because I'm about to take the antiderivative of this, plus 3, our c. F of x, we would integrate that. Okay, so let me eyeball that. I'm going to add 1. That's x to the 1/2 but I would need a negative 4 out front. 1/2 times negative 4 would be negative 2, and then subtract 1, so we're good there. Plus 3x plus c. So we have f of 0 equals 0. So y is 0. Y is equal to negative 4 times the square root of 0 plus 3 times 0 plus c. So c is just equal to 0. So I can get my final answer. F of x is this right here, negative 4 root x plus 3x. And c is 0, so I can stop there. So that does it for test review A. And I will talk to you on test review B. By the way, how would you check this? Take the first derivative, all right, and then take the second derivative, and you should end up being back to x to the minus 3/2. Okay, that'll do it, and I'll talk to you on the next one.